Now that we've installed the analysis tool packer, the data analysis add-in, let's use it to analyze monthly returns in the 1990s on GM and Cisco. There are some other stocks here, but we'll just focus on GM and Cisco here. Okay, so we go data analysis, which we now see because we've installed it. And then there's plenty of options here, but what we really care about is descriptive statistics, which is right here. We'll be using a bunch more of these things later in the course though. Okay, so now we got to fill in this dialog box. So the input range is our data, and I like to include the labels. So I'll start right here with GM. I do Control-Shift, right arrow to go to the right, down arrow, I go to the bottom. That picks off my data. The data is in columns. Output range is the upper left-hand corner of where I want Excel to put its statistics. I can just say right here, let's say I6. Then you have to check summary statistics or you won't get any. So you click OK, you'll get summary statistics. Okay, now we might make that a little bit bigger, boldface it. Okay, so now what we want to do is really compare GM and Cisco on 3 dimensions. Remember we said typical value. Now the question would be mean or median or mode here. Okay, so the mean is right here. So GM averaged about 1% a month returns, Cisco about 5.5%, and median, which you know half the data is below it, half the data is above it. GM's median was actually slightly negative. Cisco's median was 5%, which is fairly positive. There is no mode. Remember, mode is most frequently occurring value. Again, let me highlight basically, let's say in yellow, what we use for typical value. So there's no mode for GM, and the reason for that is because no return on GM occurred more than once. And for Cisco, the most frequently occurring value was 5.1%. We don't use that too much. But the question is, for typical value, should I use the mean or the median? And it depends on skewness, it turns out. If you have lots of skewness, and there's a measure of skewness on the output, there's a skewness value here. Okay, and we'll define what we mean by lots of skewness in a minute. Okay, if you have lots of skewness, and basically that generally means that skewness measure, if it's greater than +1, it means it's very positively skewed the data, or the skewness is less than -1. If you have a lot of skewness, we'll have a great example of this in a minute, you should use the median. Because basically what happens is the extreme values basically distort the typical value. If you look at income, that's a very good example where there's a lot of skewness. If somebody has an income of $100 million a year in a small town, they would greatly raise the mean. We'll see an example of this in a minute, but they really wouldn't do much to the median, and their $100 million a year is not really the typical person, okay? So we look here, we don't have much skewness. We would use the mean for typical value. So Cisco does better than GM typically, higher mean. Now what about spread about the mean? Which stock has more spread about the mean? Well, we learned a couple of videos ago, you look at the standard deviation and the variance. And so the standard deviation is what we usually like to use. It's the square root of the variance. You really need the variance to get to the standard deviation, but once you have the standard deviation, that's enough. So standard deviation on Cisco is 12.2% on the monthly returns. On GM, it's about 9%. So there's more spread about the mean for Cisco. And then there's not much skewness. These numbers are very close to 0. Again, greater than +1 is positively skewed, less than -1 is negatively skewed. So basically not much skewness. And we saw that in the histograms that we had for GM and Cisco. Fairly symmetric data sets. Now, a more powerful example about why you don't always want to use the mean for typical value, though people like to do this, is based on real situation. Let's talk about 1984, and this really happened. If you're a basketball fan, you might think about this. And even if you're not a US citizen, I think the person I'm talking about you've heard of, because he was one of the most recognizable people in the world. Okay, so let's look at 1984. University of North Carolina, a great school, geography majors, had the highest average salary. This is true, a friend of mine told me, at the University of North Carolina. Okay, so should everybody have wanted to be a geography major? So let's suppose there were 15 geography majors who averaged $40,000, who got made $40,000, and one made $1 million. This isn't that far from the truth. Now, if you look at the median, you know that's going to be the midpoint, between the 8th and 9th largest salary. That's going to be $40,000. That's a much better measure of the typical income of a geography major than if I average these numbers. I mean, we'll skip ahead. There's a function average, which we'll learn about later, but I think most of you know that one. What was the average salary for geography majors? $100,000, and it's indeed true. The highest average salary for 1984 geography majors at UNC, the highest starting salary for majors in any academic major at UNC was geography majors. So should everybody have been a geography major? But the median salary was surely higher for, let's say, accounting majors or computer science majors. What was going on? Michael Jordan was a geography major. As we know, we can't all be like Mike. I mean, that's probably a slogan. And so basically, we shouldn't have looked at the mean salary of geography majors. We should have looked at the median, or the typical value. And so basically, here's a great example. There would be a lot of skewness. Again, skipping ahead a bit, there is an Excel function to measure skewness. And if you would look at the skewness of this data set, you get a skewness of 4, which is much bigger than +1. So our rule would tell you to use the median income to measure basically a typical value for a UNC geography major's income rather than the mean. Now in the next video, we'll show how you can take the mean for a data set and the standard deviation and put them together and try and understand the typical range for a data set, which is very important, and also spot unusual data points known as outliers.